Hey, what's up, Algebra 2? It's Ryan. Today we're going to be working on law of sines and law of cosines. So not every triangle you'll come across is going to be a right triangle. And so in those cases, we want to know how to solve for some unknown side lengths or angle measures and have some formulas to help us do that. And so that's where law of sines and law of cosines are going to come in. So I've seen both of these formulas show up on SAT questions. Obviously, it's going to be expected of you to know this in this Algebra 2 course. So it's important that we understand it and we know how to apply it to some real world scenarios too. So let's just jump into this and talk about law of sines to start us off. So we have this triangle ABC where capital A is the angle across from side A, which is this little a, and capital B is the angle across from this little side B, and same for C. So what law of sine states is that sine of big A, of angle A, over side A is equal to sine of angle B over side B, which is also proportional to sine of angle C over side C. And so this is law of sines. All of these are proportional to one another. So we're just looking at the ratio of the sine of an angle divided by the side across from that angle. Okay, and all of these are proportional to one another, and we can use this law of sines in three cases. First, when we have two angles, so that would be AAS or ASA, and so that side can either be outside of those two angles or between those two angles. It doesn't matter. And that's also just because when we have two angles, we know that all three angles within a triangle sum to 180, so we can solve for that third angle. We can also use it when we have SSA. Okay, so let's start and try to put this into just apply. Sorry, it's kind of early in the morning. Okay, so we have this triangle. You know what? For this first one, I'm going to label it. Okay, so this is angle A, this is angle B, this is angle C. And we have X, and I'm going to say little c, and this is going to be 10, which is little b. And I'm going to say little a here, actually. Okay, perfect. So what law of sine states is that sine of big A, so sine of angle A, which in this case is 52. So I'm going to say sine of 52 divided by the side length of the side opposite of that angle. So that would be this little a, which is equal to x, is equal to sine B over B or sine C over C. So in this case, we want to see where do we know angle B or little b or angle C and side C. And so in this case, we have this pair, where we have angle B, which is 34. So I'm going to say sine of 34. And then we have side B, which is equal to 10. And so from here, we can just cross multiply and solve for x. So I can multiply both sides by 10x, and I end up getting 10 sine of 52 equals x sine of 34. Okay, and then at this point, I can Really, actually, you know what I'm going to do right now is I'm going to evaluate this. So I'm going to take out my calculator. I'm going to check that we are in degree mode. And we do that by pressing mode at the top. And you should see on that third line that degree is highlighted rather than radian. And so now what I'm going to do is I'm going to say sine of 52 and evaluate that. And I got 0.79-ish and multiply by 10. So right now on this side, we have 7.88 equals, and then equals sine of 34 is equal to 0.56. So this equals 0.56x. Now I'm just going to divide both sides by 0.56. So I end up doing 7.88 divided by 0.56. And I end up getting about 14.1. So x equals 14.1. And that would be our side length for x. Okay? So that's where we can use law of sines to find that unknown side length. Okay, so now let's do this one more time. Except, yeah, let's just try this one more time. So I'm not going to label this, but I'm going to look for cases where we have a angle and a side length across from that that we either already know or we're trying to figure out. And two pairs of that, so we can set up an equation like we did in number 1. So we have 110 and x, which are across from one another. So I can say sine of 110 over x. And then I look and I see that we have side length 19, which is great. And then I look at the angle across from that, and we don't know that yet. But what we do know is we have 2 angles. And so what we can do in that case is we know that all 3 angles in this triangle sum to 180. So we can use that to solve for the third angle. If we already have 110 and we have an angle equal to 110 and another angle equal to 41, these 2 angles combined have a measure of 151. So we can just subtract 151 from 180 to get 29. So that's going to be the angle measure across from 19. And so now we can set up this proportion where we say sine of 29 degrees over 19. Because that angle, 29 degrees, is across from side length 19. Okay, so now we just solve for x like we did before, where we cross multiply and do 19 sine 110 equals x sine 29. And then I'm just going to evaluate it at this point. You can move this sign over and then evaluate it after that. I'm going to do it before. It does not really matter. And so on this left side, I'm getting 17.85. And on the right side, I'm getting 0.48. So now we just divide both sides by 0.48. So 17.85 divided by 0.48 would give us about 37.2. Sorry, I don't know why it looks like that. Okay. Great. Okay, so now let's use that same law of sines to help us find angles when we have SSA. So let's think about a sine function, right? We haven't really talked about graphing sine functions yet, but let's think about our unit circle, which we talked about last lecture, right? A unit circle is a circle with a radius 1, and we have, right, last time we created all these, that's actually a good circle. We created all these triangles within it. But sine, right, we said sine of theta was our y value. So that means we want to look at our max y value across this entire circle, max and minimum. And that comes at these 2 points where y equals 1 and y equals -1. So that means sine equals 1 and sine equals -1. And it can fluctuate anywhere in between. So the sine function always has a range between -1 and 1. Okay? If the sine function is positive, then the angle can lie in either quadrant 1, which is here, or quadrant 2, which is here. And that's because our sine function, right, that's our y value, and if that's positive, that means it has to be above the x-axis, and so that occurs in quadrant 1 and quadrant 2. To find the other possible angle, we'll have to subtract from 180. And we do that because, say we have a y value that's equal to something here, we have that same, we can get that same sine value or that same y value at a different angle when it's just a cross line, and so we subtract that from 180 to get that other angle. Same thing if it was up here versus here, things like that, because they're all have the same y value, the same sine value. Great. Now the sum of the angle measures in a triangle is always equal to 180 degrees. We talked about that before. And no two triangle can have two obtuse angles, right? Obtuse angles means angles that are greater than 90 degrees. And right, if we have two angles that are greater than 90 degrees, now we've already surpassed this 180 degree mark, and now that is not possible. So let's use this to solve some problems here. So I'm actually going to draw a triangle for number 7, so we can visualize this. Okay, so measure. Now I'm just going to kind of draw any triangle. I don't really know what this triangle will look like, but it does not really matter. Okay, so say we have a triangle. I'm going to say this angle is equal to 5, or A. And I'm going to say this is B and this is C. And so that means this side would be little a, this side would be little c, and this side would be little b. So that means measure of angle A by given, since we're given this in our problem, would be equal to 50 degrees. And measure, or side length AB, which is across from angle C, is equal to 4. And then side length BC, which is across from angle A, is going to have a side length of 9. So now let's set up a law of sines so that we can find the measure of angle C, which is this angle. So I realize that we have this angle A and this side little b across from one another, so I'm going to set up a proportion where I have sine of 50 degrees over 9, right? Because these are across from one another. And then I also noticed that what we're trying to figure out, the measure of angle C, so we're trying to solve for that angle, we have the side length across from that, which is 4. So notice AB, the side length AB is across from angle C. So if you did not draw this out, you would just want to look for the side length that has those two points AB. Oh no, that side is across from angle C. I don't know how to describe it. It's just the other 2 points in that triangle. I don't know. We'll use that in future problems, but it doesn't matter. Okay, so I'm gonna say sine of x, since we're solving for that angle measure, over 4, right? And now I'm gonna multiply both sides by 4 so I can get sine of x by itself. So I end up getting 4 sine of 50 over 9 equals sine of x. Now, 4 sine of 50, let's evaluate that. So 4 times sine of 50 degrees gives us 3.06 roughly. And then we divide by 9, and we get 0.34. So 0.34, I'm just going to switch the sides of this equation. Sine of x equals 0.34. And now we find the value of x by taking inverse sine of both sides, so arc sine. And so you'll see that on your calculator in blue above the sine function. And so we end up saying, essentially we do x equals inverse sine, so it should look like this, of 0.34. And when you do that on your calculator, and you do that by pressing second sine, inverse sine of 0.34 would give us 19.9, okay? So we get, I'm gonna write this here. We get x equals 19.9 degrees. But we also wanna remember what we said up here, that to find the other possible angles, subtract from 180. So 180 minus 19.87, whatever, would give us 160.1 roughly. So our other angle would be 160.1. But we want to check, okay? If this angle C is equal to 160, or we just want to plug in our possible values of x for angle C in here and use what we know about triangles and how they always sum to 180, and use that to see if it would be a plausible answer. So for example, when we plug in 19.9 for angle C, that works because we have 19.9 plus 50 plus whatever angle B that can sum to 180. Whereas if we plug in 160 for angle C, 160.1 plus 50, now we're already at 210.1. 210.1 degrees is obviously greater than 180 degrees, and so this would not be a plausible answer. And so we always want to plug it in to see if it's that value of x is viable. So our final answer is that x equals 19.1 degrees. Okay. Now let's try number 8. Okay, so I'm not going to draw this out, but we're going to try to solve this without drawing it out this time. So we're given angle B, side AB, and side AC, and we're trying to find the measure of angle C. So I know that measure of angle B is across from AC, so these two are pairs, right? Just because B is by itself and AC are the other 2 points in the triangle, and so that means they must be across. That was what I was trying to say here. So I know I can set up a proportion where I have sine of 37 over 29. That's going to be half of my equation. And then we have side AB is 47. We're trying to find measure of angle C. And we also know that those two are across from one another because we have AB and then C, and they're all separate, right? AB are the 2 points across from angle C, and they're connected, so they form that side. Okay, so now we have sine of angle C, which I'm just going to say X, over 47. So now we do the exact same thing. We multiply both sides by 47. We end up getting 47 sine of 37 over 29, and that's equal to sine of X. So 47 times sine of 37 divided by 29 gives us roughly 0.975. So I'm going to say 0.98. 0.98 equals sine of X. And then we just take the inverse of that. So we say inverse sine of 0.98 equals X. And that equals, right, actually let's just move to the side. So when I evaluate that on my calculator, I end up getting 77.3-ish. 77.3 degrees. And then we also want to subtract that from 180. So 180 minus that would give us 102.7. And so now we want to plug this into our triangle to see if these are both viable angles. And so 77.3 plus 37, that gives us something probably around 114-ish. And so we have a bunch of room for that third angle, angle B or angle A, to fill that gap and bring us to 180. So we're good. 102.7 plus 37, that's also less than 180, so we're good. So we from here, sorry about that. So we know that both of these satisfy that that property that we know that all angles in a triangle must sum to 180. So these two angles should their sum should be less than 180, and they both are. So we know that these are both viable answers. So we say that I'm going to say measure of angle C equals 77.3 degrees or 102.7 degrees. Great. Okay, now let's do problem 10. Okay, so we're given that measure of angle A is equal to 114 degrees. We're given that side AB equals 34, side BC equals 12, and we're trying to find measure of angle C. So let's look for any pairs that are opposite of one another. So we have measure of angle A, and that is across from side BC. So that's a pair right there. So we can say sine of 114 over 12. And now we want to look, and we have another pair here, right? Angle C and side AB are across from one another. So we can say sine of angle C, which I'm just going to say X, since we're solving for that, over 34. You know the drill, we multiply both sides by 34. I'm going to keep on writing it out just so you can see. And that's equal to sine of X. So now we evaluate that left side, so 34 times sine of 114 divided by 12, and I'm getting 2.58 equals sine of x. Now let's just take a second and think about this. Before, we said that the sine function always has a range between -1 and 1, because when we looked at this unit circle, we know that our max value is 1, our max y value is 1, and our max y value, or our min y value is -1. And so now we're getting that sine of x equals 2.58. That means our y value would be something probably way up here, something along this line. So that doesn't look plausible. This there's no x value that makes sine of x greater than 1. So we know that this isn't plausible. And in fact, when you do inverse sine of 2.58, you get an error, okay? So this would not be plausible. There's no value of x that makes this equation true. So we can say no solutions. Great. Perfect. Okay, so now let's move on to law of cosines. So we have this same triangle where all these capital letters are representing angles, and then the lowercase of that same letter is representing the side across from that angle. And so we can create essentially 3 forms of an equation where we say, first, I'm going to write this equation, c squared equals a squared plus b squared minus 2ab cosine of c, of capital C, okay? And you notice, real quick, this looks very familiar, right? Look at this first part, c squared equals a squared plus b squared. This is just a more specific formula for the Pythagorean formula. Let's draw a right triangle here. I'm not going to go on too much of a tangent. But let's say this is angle C. This is A, this is B, this is little c, this is little a, this is little b. A squared plus b squared equals c squared. But notice that we have this minus 2ab cosine of c. In a right triangle, this angle C is 90. Think back to your unit circle. Cosine of 90, right? Let's go up here. Cosine of 90, that would bring us to this point. What's our x value since cosine is x at this point? It's 0. So that means we'd have cosine of 90, which is equal to 0. And when we multiply all this, that essentially negates this entire term. And so we're just left with c squared equals a squared plus b squared, which is the Pythagorean formula. So essentially, the Pythagorean formula is a law of cosines equation, except more specific. Or except specific to one case where angle C is a right angle. Okay? So that's pretty neat. And so anyways, this is our law of cosines equation. But we can do that for any side. So we can have b squared equals a squared plus c squared minus 2ac cosine of angle b. We can have the same for a squared. A squared equals b squared plus c squared minus 2bc cosine of a. And so you notice how I sort of remember this is we have that a squared plus b squared are those two sides squared, almost like the Pythagorean formula. And then we just take those side lengths and we use that when we subtract 2 times those two side lengths multiplied together times the cosine of whatever angle is opposite of the side we're trying to find. Okay, so let's try to put, I know I just gave you a bunch of different formulas. Let's try to put that into practice here with problem 1. So actually, I'm going to label all of these sides at first, just so we can get a little bit of a better understanding. We know how to plug some of these in. Okay, so we're trying to solve for side x, which is across from angle A. So we're trying to solve for little a. So I'm going to use this last formula, okay? And they're all essentially the same formula. It's just you're defining A, B, and C on different sides. But I'm going to use this last formula. So I'm going to say a squared or x squared equals b squared. And so b squared is this side length, which has 23 as its side length. So 23 squared plus little c squared, which is 9, so 9 squared. And then minus 2 times b, which is 23, times c, which is 9, and then times cosine of A, of angle A, which is opposite of the side we're trying to solve for. So that means cosine of 71. Okay, and so now we can just evaluate this entire right side of the equation. We have x squared equals 23 squared is 529. So I'm going to say 529 plus 9 squared, which is 81, minus 2 times 23 times 9. I'm just going to do that out. 2 times 23 times 9 is 414 times cosine of 71. Sorry, so I'm actually going to evaluate what cosine of 71 is. Cosine of 71 degrees is 0.32, 326-ish. So I'm going to say 326. And now we just keep on evaluating that. So 529 plus 81 brings us to 610. 610 minus then 414 times 0.326, which I'm actually, times that would give us 134.79. 134.79. And now when you do that all out, 610 minus 134.79 gives us 475.2. Or sorry, 475.2. And then we want to take the square root of that, right? Because x squared equals 475.2. And so the square root of 475 would give us about 21.8. So we, x, I'm going to write this out. X equals the square root of 475.2. And that equals 21.8. And that's going to be our final answer. Okay, great. Now let's apply this again in problem 3. So we have a triangle ABC where a measure of angle B is 106, AB is 10, and BC is 7. So in this case, actually, I'm going to draw this out because I think it's going to be helpful. So we have 106 as B, and we're solving for side AC. Okay, I don't know how accurate this is. I don't know what this triangle looks like, but actually I'm going to draw this off to side. Sorry about that. Okay, something like that, where this is angle B, which is 106, and this we'll say this is A, and this is C. So BC is 7, AB is 10, and we're trying to solve for this opposite side, AC, which is, we're going to say X. So let's try to use our law of sines equation, okay? So if we think about this, we're solving for this opposite side. So we're solving for x squared again, just like we did before. So I'm going to say x squared equals, and then it's our two other sides squared. So 10 squared plus 7 squared. And then we're subtracting 2 times those two sides multiplied by one another. So 2 times 10 times 7 times cosine of that angle opposite to the side we're trying to find. So cosine of 106. Okay, now we can just evaluate this. So 10 squared is 100 plus 7 squared is 49. So 100 plus 49 is 149 minus, now 2 times 10 times 7 is going to be 140. So I'm going to say minus 140, and then cosine of 106 is equal to, I'm going to say, negative 0.276. Okay, so now 140 times that value of negative 0.276, we get negative 38. And so now we have, I'm going to keep on writing this, I'm going to say x squared equals 149 minus negative 38.6-ish. And we have a minus, so make sure not to get tripped up on that. We're adding these two. And so we do 149 plus 38.6. And so we should get something around 187. So we end up getting 187.6. And now, just like before, we take the square root. We say x equals the square root of 187.6. And that gives us a value around 13.7. And that's going to be our final answer. Okay? So that's how we apply law of cosines when we have two sides and an angle. Now let's try to use law of sines, or law of cosines, my bad, to solve for an angle rather than a side. So in this case, we're given all sides, but we're trying to find this angle x. So that means, in this case, we know CAB, but we're trying to solve for angle C. So I'm going to plug in all of our values that we know. Okay, so since we're solving for angle x, actually, this might be helpful to write this out. I'm going to label this as A, this is B, and this is C. So this would be little b, this would be little c, this would be little b. Sorry, not, why am I saying this would be little b? That's my bad. This is little a. Okay, so in our formula, let's actually zoom out and look back up here. In our formula, if we're trying to solve for angle A, we have angle A in this third equation. So I'm going to try to write out this third equation. So I do little a, the side across from the angle we're trying to solve for, squared. So I'm going to say 8 squared equals, and then we have those other two sides squared and added. So we have 10 squared plus 11 squared. And then we do minus 2 times both of those sides, so 2 times 10 times 11 times cosine of that angle we're trying to solve, so cosine of x. Okay, great. Now we have this equation written out. So let's try to simplify this. So we have 64 equals 10 squared is 100, 11 squared is 121. So added would give us 100 plus 121 be 221 minus 2 times 10 times 11. So 2 times 11 is 22 times 10 would be 220. So I'm going to say minus 220 cosine of x. So now we just have to simplify. So I'm going to subtract 221 from both sides. And that's going to give us negative 157 equals negative 220 times cosine of x. And now we have to divide both sides by negative 220, or actually I'm going to say both of these are positive. Divide both sides by 220, and 157 divided by 220 would give us 0.714. I'll write that here, 0.714 equals cosine of x. And now we do sort of what we did before, and we take the inverse cosine of that. So I'm going to say inverse cosine of 0.714. And when I do that on my calculator, sorry, wait, let me, my bad. Okay. So when I plug that into my calculator, I get 44.4, or sorry, 44.5 degrees. And that would be our final answer. Great. Okay, so now before I finish up this lecture, we'll apply this to one word problem, okay? So we're given this question. Maple Street, Oak Drive, and West Avenue intersect to form a triangular piece of land. The angle formed by Maple Street and Oak Drive is 79. If the Maple Street section of the triangle is 390 feet and the Oak Drive section is 250 feet, find the length of the West Avenue section. So we're given 3 pieces of information: 2 side lengths and then an angle measure. So let's try to draw this out. So we have something that looks like this. Oh no, that looks kind of, I don't know. Let me see, maybe something. I don't know, something like that. Okay, this theoretically is 79, or I'm gonna first I do this, let me see. So this is Maple Street. I'm going to say this is Maple. This side is Maple. And I'm going to say this side is Oak. And then I'm going to say this side would have to be West Avenue. So I'm just going to say West. Okay, perfect. So this angle between Maple and Oak is 79 degrees. This section of the Maple Street is 390 feet, so 390, and Oak is 250. And we're trying to find the length of West Avenue, so that's going to be X. So let's set up our law of law of cosines equation. So we're trying to solve for this side, and we already have the angle opposite to it. So we have, and then we have two other sides. So we should be able to solve for this equation. So I'm going to say x squared equals the two other sides squared. So 250 squared plus 390 squared. And then I'm going to do minus 2 times both of those sides. So 250 times 390 times cosine of that angle we're trying to solve. Or sorry, we already know the angle. That's my bad. Cosine of 79. Okay. And so now we just have to evaluate this. And so we do x squared equals, now 250 squared gives us 62,500. 390 squared gives us 152,100. When we add those together, we get 214,600. So I'm going to say 214,600 minus, and then 2 times 250 times 390 gives us 195,000. So minus 195,000 times cosine of 79. Or sorry, we can evaluate what cosine of 79 is. So cosine of 79 would be 0.19. So now we have 214,000 times 214,600 minus, now 195,000 times 0.19 gives us roughly 37,200, and I'm going to say 208. And then when we subtract those, we get x squared equals, so 214,600 minus that 37,208 gives us roughly 177,392. So when we take the square root of both sides, sorry, I don't know why this looks all weird, we get x equals, and then we should get 421.2-ish. 0.2, and that would be in feet. Perfect. Okay, and so that's how we would apply law of cosines to solve one of these word problems. Okay, so hopefully you've learned a little bit from what we've talked about today, both about law of sines and law of cosines and how to apply them when we know two angles versus when we know two angles on one side versus when we know two sides and one angle, and all these different configurations to find some unknown side lengths and angle measures of various non-right triangles. If you have any questions about what I talked about today, please reach out to me, talk to your teacher, go to the tutoring center. Just seek out resources you need to make sure you understand the material and you feel confident on it and can do it independently, do it proficiently and efficiently. Yeah, just have a good day. See ya. Bye.